get $2 every time you buy a ticket. At what point do you break even? Is it worth it for you to keep buying tickets? What point do you make money? What is your expected value you're getting on your return? Now, an easy way to do expected value normally is it's the same as the mean. As we do the, your table we did with your P of X, and we did the X times the P of X, and we added that down to get the mean. God bless you. That's expected value. That's like the average thing that will happen. Now, in terms of lottery tickets and things like that, an easy way to do this is with the table. So, say for instance, you have a raffle, and there are 1,500 tickets sold, and they're selling for $2 each. So, automatically, when you buy a ticket, you're in the hole $2. If you don't win, you lost $2 for every ticket that you purchased. There are 4 prizes. One prize wins $500. One prize wins $250. One prize wins $150. One prize wins $75. You buy one ticket. What is the expected value of your game? Now, when we figure this out, we're going to figure out what the probabilities are. And then we're going to multiply the X times the P of X to get that. That is the same as your mean when we did your table. We put it in your calculator, L1, L2. You can do the same thing in your calculator, L1, L2. And you can let your calculator do it. It's the same as your calculator does. But to work this out, just to show you, you're going to, on your $500 ticket, you've already spent $2. You're only going to make back $4.98. There's only one of those prizes out of 1,500 tickets. To make $2.50, you've already spent your $2. You're going to get back $2.48. There's only one of those tickets out of 1,500 tickets. To win $150, you spent your $2. You're going to actually win $148. And then for your 73, you're going to win your 75, you spent your $2, you'll get back your $73. If all else fails, all the rest of the tickets, there are -4. There are 4 winners. So there are 1,496 non-winners, losers, losing tickets. And we're going to take this probability too and multiply these. Now, the only reason why this looks different is because it's horizontal. We did this before, X, P of X, and then we multiplied those 2 columns. Or we did an L1 and L2. Okay, this just happens to be horizontal. So what they're saying is if you do this times this, this times this, this times this, and then you add them all up, you get your mean, or you get your expected value. This is what you expect to happen with a raffle of 1,500 tickets. Now, you probably hear different people say, oh, if I buy every ticket possible, I'll win. But at what point is that worth it? How many tickets do you have to buy in order to win? Okay, you'd have to buy all of them. You'd be the only person in here. You're obviously not going to be able to buy all of them. And if you bought all of them, do they add up to the 1,500 times 2 that you had to pay? You'd have paid $3,000. Does that add up to $3,000? You'd be losing money. So first of all, you can't purchase all the tickets because you'd absolutely lose money. And you got to see where's your expected value out of this. So what they're saying is the same how we wrote this. We said $4.98, we said 1 out of 1,500, and we multiplied them, and then we took the sum. So they're just doing it like this. 498 times 1,500 plus 248 times 1,500 plus 148 times 1 over 1,500 plus 73 times 1 over 1,500 plus -2 times 1,496 over 1,500. This is what you can expect to get back, your expected value. Now, if you look to the bottom of the page, they worked all this out. It's a negative 135. In other words, for every ticket you purchase, because the expected value is negative, for every ticket you purchase, you could expect to lose $1.35. You're not going to come out, well, obviously if you bought one ticket, you get lucky, that's your probability of winning, but your expected value over the long run here is the average that comes out of this. And can we put it in your L1, your L2, and figure out your mean? Absolutely. This doesn't work any differently, but you have to be able to set up your probabilities. You have to look at each payout and each probability.
Your mean is your expected value?
Your mean actually is your expected value. On the average, what will happen? You will lose $1.35 over time on the average. With these, it's kind of hard to see. Expected value works better like in like a gambling type thing. Expected value, what is your return? You know, things that you're doing over time. But for us, and there's a whole course on expected values and probabilities. For us, we're just considering it our mean, what we expect to happen over time. So if you take a look at example 7, they do the same thing with 2,000 raffle tickets. I want you to set up a graph, a chart, based on 2,000 raffle tickets, selling at $5 each. And there are 5 prizes. I want to know the expected value of your gain when you buy a ticket, on the average. So you're going to set up a chart. Your expected value is take these two, L1, L2, and look for the mean. It's going to multiply these guys, add them all up, and that's what gives you your mean. But let your calculator do it. Let your calculator do it. I did it all out by hand. Isn't this what your calculator gave you? This times this times this, that times that. Add it all up. There's your mean. Yes. So just make sure all your entries in your table are good. Because that 455 should be 495. Yeah. Usually it's just because one of your numbers is off. Well, because they changed the prices on you. They made it 2,000, 1,500, 250, 100. It's not like the other one where it was like a pattern. So over the course of time, you're expected to lose money. And like I said again, if they offered all these and you bought your 2,000 tickets, it would cost you $10,000 to buy every ticket to win. But you're not winning back $10,000. Over the course of time, you're not winning that money back. You're expected to lose if you did that. So that's what expected value is. It's just your mean. It's your mean. Your mean is x times the p of x, and take the sum of that column. Can you still put it in your calculator for L1, L2? Yes. So the word I want you to associate with expected value is the mean. Wherever you build a table and find your mean, that's your expected value. Now, just to look at a couple of the questions. Just to look at a couple of the questions. I don't know what's going on here. I think this is Mr. DiCaprio's thing. Just to look at a couple questions on page 200, if you would. Number 35. Number 35 says this. The expected value of an accountant's profit and loss analysis is 0. In other words, he doesn't expect to win. He doesn't expect to lose. That's a safe way. That's his break even. He's going to have a break even point. If you invest something and you don't expect to win any money and you don't expect to lose any money, you broke even, right? You didn't lose anything. So if your expected value is at 0, that's called your break even. That's a safe way of playing something. You win, you lose. All over the long run, you didn't lose anything. Kind of like playing cards with fake money. You know, it doesn't really matter. You have fun. You didn't lose anything. You didn't win anything. But this is when you have your money changing hands. Your gains is equal to the money that you spent. Your gains equals your losses, and you break even. Just to look at some ways that they phrase these. I thought I did two of them. I didn't. Look at number 36. That's another one. Number 36 says, in a game of chance, what is the relationship between a fair bet and its expected value? What would be a fair bet? What do you think they consider fair? Equal. Equal. Perfect. It's fair, it's equal. It's balanced. So again, you would be at a break-even point. If it's a fair bet, your expected value would be 0. It means you have an equal chance of winning and losing. Almost like the concept of a fair coin. You have an equal chance of getting a head as getting a tail. A lot of times when they flip a coin, they say a fair coin, a fair die. You need equal chances. And in probability, that's what they're looking at. You know, you don't want to be flipping a coin that's not same probability as heads, the same probability as tails. You may be on the losing end of it. Okay, so just that you associate your expected value with your mean. Good? Okay. Possible outcomes. Now, 2 possible outcomes can also mean I roll a die. I am looking for the probability. I want to roll a 3. So either I get a 3 or not a 3. That's still a binomial. Something's wrong on this side of the board with my board. It still can have more than one thing, but you're only asking for 2 outcomes. I spin a spinner. On my spinner, this is red, white, blue, green. There's 4 possible things that can happen. I want to know what the probability of red is. Which is what? 1/4. 2 choices. That's my success. My failure is not red. My complement case. 3/4. So when we do binomials, we can lump all the other parts into the not part. It doesn't necessarily can only be only two outcomes to that event. We just lump them all together to be the not part, the complement. This is the complement. It's important to be able to pull out your probabilities. Your binomial experiments have the same characteristics as your probability ones do. Remember, to be a probability experiment, your probabilities have to be between 0 and 1, and all your probabilities have to add up to 1. That has to happen, but in addition to that, we have a binomial part of this. There are 2 possible outcomes, a success and failure. I don't know if you remember, we called them P and Q back in Algebra 2. We called them a P and a Q. This is repeated for a fixed number of trials. Usually it says n is done for 5 times, n is done for 3 times. I do this 7 times. I look for the days that it's raining 6 days. And each trial is independent. This is important. The probabilities remain the same when it's independent. The probabilities cannot change. They are fixed. And our random variable x represents all the possible outcomes. In other words, I want to toss this die 3 times. I want to know what the probability is of getting 3 threes. So, or 2 threes, or no 3s. So I'm going from n is 3. I'm going from 0 to 3. I'm still building my table like that.
You like say you did wanted it 2 times, you would put it to like you would flip it to the palette.
Yeah, you're thinking of this side. See? Were you thinking of this? Like 3 things 2 at a time if you wanted 2 of them.
You put it to the square and then you put it to
Yes. That's what we're going to be doing. However, guys, hang on 1 second. Instead of doing this, there's a calculator one, and we're going to build a table from this. And then from your table, instead of your oars where you had to keep stringing them all out, we're going to use the results in your table. So tomorrow, this is where we're starting, right here. Tomorrow when you come in, get your books, and let's get started to work.